Hi, good morning. This is Nitya, Assistant Professor at Sri Sharma College of Pharmacy. Today we are discuss about theory of indicators. First, introduction. Indicators are analytical agents that undergo a distinct and observable change. Example, usually color, sometimes turbidity or fluorescence at or near the equivalence point of a titration. They do not participate in reaction, instead, they reflect changes in pH, redox potential, or complex formation. Selection of a suitable indicator is essential to ensure accuracy, precision, and reproducibility of titometric analysis in pharmaceutical quality control. Next, definition. An indicator is a substance that changes its physical properties in response to a specific chemical range in an analyte or titrant system. Next, classification of indicators. They are classified into further categories. First, acid base indicators. Weak organic acid or bases exist in unionized or ionized forms with different colors. Example, phenolphthalein, methyl orange, bromothymol blue. Next, redox indicators. It undergo the oxidation reduction reactions to exhibit the different colors in oxidized and reduced forms. Example, ferroin, diphenylamine, methylene blue. Next, absorption indicators. They are used in precipitation titration, especially in argentometric titration. The color changes due to the absorption of dyes on precipitate surface. Example, fluorescein, eosin, dichlorofluorescein. Next, complexometric indicators form weakly stable complexes with metal ions. It color changes when metal indicator complex is displaced by a stronger ligand. Example, EDTA. Erythrone black tea, calmagate peroxide. Next, the theory of indicators involved some theories or source. First, Oswald's ionization theory, acid base indicators. Indicators of weak acids or weak base. H ion and ionization have different colors during titration as pH changes, equilibrium shifts. Indicators change color when it explains pH transition range, usually 2 minutes. Limitations or Oswald ionization theory. It cannot explain indicators where the color change arises due to the structural rearrangement and not simply ionization. It does not explain indicators that changes due to the oxidation or complexation. Next theory, coinoid theory. The other name, structural theory. This theory explains our color changes by tautomerism. In the indicators exist in two structural forms. Benzenoid form one color, coinoid form another color. Change in pH or ionization shifts equilibrium between the forms. Example, phenolphthalein, colorless lactoid, benzenoid form, pink coinoid formed in alkaline pH. There are advantages in coinoid theory. It explains why some indicators show color only in specific pH ranges. It explains indicators where the ionization theory cannot. Next, redox indicator theory based on Nernst equation controlling the redox potential. Oxidized form in bracket INOX, redox form IN red have different colors. The indicators changes color when the system's potential equals the indicator's standard redox potential. Example ferroin, red ferroin complex, blue ferroin Fe3 plus complex. It is oxidized. Next, absorption indicator theory used in Fajon's method, agentometric titration. The indicators ions observed to precipitate the surface. Before equivalence, the precipitate surface negatively charged, anionic indicators repelled. Next, after equivalence, surface become positively charged, indicator ion observed color change. Example, fluorescent turns pink when observed on silver chloride precipitate after the endpoint. Next, complexometric theory. Indicators form weakly stable colored complexes with metal ions. EDTA forms a much more stable metal EDTA complex freeing indicator. Example, erythrone black tea, wine red to blue. This is free indicator. Next, characteristics of a good indicator. Sharp and distinct color transition, color change close to equivalent point, highly visibility, stability in solution, not interface chemically with unlight or titrant, easily available and inexpensive. Next, selection of indicator. Indicator's choice depends upon the pH at the equivalence point. There are the titration type, strong acid versus strong base, the pH endpoint 7. The indicators are phenolphthalein, promethymal blue. Weak acid versus strong base less than 7 is the endpoint. The indicators are phenolphthalein. Strong acid versus weak base greater than 7 is the indicators used in methyl orange. Weak acid versus weak base, no sharp endpoint. The indicators are potentiometric preferred. Next, there are the common indicators with the pH range. Methyl orange in acid, red in base, yellow. pH range is 3.1 to 4.4. Phenolphthalein acid in colorless, base is a pink, pH range 8.2 to 10. Next, promethymal blue, acid in yellow, base in blue, pH range 6.0 to 7.6. Alizarin yellow, acid in yellow, base in red, pH range is 10.1 to 12. Next, the applications. The pharmaceutical titrations, HLSA, NaOHSA, CaCO3 assay, water hardness determination, chloride estimation, redox titration, dissolution testing, buffer preparation and analysis. They are the lot of applications were used in indicators. Thank you. Next class we discuss that.